Today we want to consider indices as a topic. The expression a raised power n means a is multiplied by itself n times. For instance, when we have 3 raised power 4, we are going to multiply 3 in 4 places. That's why we have 3 times 3 times 3 times 3, which gives us 81. And likewise, when we have 2 raised power 5, we are going to multiply it in 5 places. That's why we have 2 times 2 times 2 times 2 times 2, which gives us 32. Today we want to consider the laws of indices with its example. The first law of indices states that a raised power m multiplied by a raised power n will give us a raised power m plus n. All what we need to do is to add up the powers when we have the same base. So for instance, when we have 2 raised power 5 here, multiplied by 2 raised power 2 is going to give us 2 raised power 5 plus 2, which will give us 2 raised power 7. Then the second law, a raised power m over a raised power n, that is a raised power m divided by a raised power n, will give us a raised power m minus n. That means when we have division sign in between and we have the same base, we are going to minus the power. So for instance here, we have 3 raised power 5 over 3 raised power 3 is going to give us 3 raised power 5 minus 3, which will give us 3 raised power 2, which also equals to 9. And likewise, the third law, when we have a raised power n in brackets raised to power n, these powers can multiply each other. That's why we have a raised power m n. So for instance, when we have 2 raised power 2 in brackets and we have raised power 3 outside the bracket, is also equivalent to 2 raised power 2 times 3, which will give us 2 raised power 6. Likewise, when we have 1 over a raised power n, is going to give us a raised power minus n. This is inverse law. So when we have 1 over 3 raised power 2, it can also be written in the form of 3 raised power minus 2. Number 5, the fifth law. When we have a raised power 0 is equals to 1. Any number that is raised to power 0 is equals to 1. So therefore, 5 raised power 0 is equal to 1. And likewise, when we have a raised power 1 over n, the law stated that it will be equals to n root a. So for instance, when we have 8 raised to power 1 over 3 here, we are going to have cube root of 8, which will give us 2. And the last but not the least, if a raised power s is equals to a raised power y, if their base is equivalent, the law enables us to know that we can eliminate the base, whereas the power should be equal. So if a raised power s is equals to a raised power y, then s is equals to y, provided that the base are equal. So for instance here, when we have 2 raised power n is equals to 2 raised power 3, we can eliminate this, therefore n is equals to 3. So let's solve these examples. Simplify the following. Number 1, we have 9 raised power minus 1 over 2. 9 will be written in index form. So we are going to have 3 raised power 2 in bracket of minus 1 over 2. So these two, we eliminate these two here. We are going to have 3 raised power minus 1, which is also equivalent to 1 over 3. Number 2, we have 81 raised to power 1 over 4. This 81 is equals to 3 raised to power 4 in bracket of 1 over 4. So this 4, we eliminate this 4 here. We have 3 raised to power 1, which is equals to 3. Then the last but not the least for today, we have 1 over 4 raised to power minus 1 over 2. Don't forget that 4 will be written in indices form, which is equals to 2 raised to power 2. And we have raised to power 1 over 2 outside the brackets here. 1 over 2 raised to power 2 will also be written in the form 2 raised to power minus 2. And we have this one outside the bracket, which is raised to power minus 1 over 2. So these two can eliminate these two here. Then we are going to have 2 raised to power 1, because minus times minus will give us plus. Then our answer will be 2. So I want you to try these questions and put your answer in the comment section. Simplify the following. Number 1, 125 raised to power 1 over 3. Then number 2, 1000 raised to power minus 3. Thank you.